Hi everyone, thanks for joining today's webcast. If you've joined one of GitLab's webcasts in the past, or perhaps you've seen our recorded webcast on our YouTube channel, you're probably thinking that it's been a while since our last webcast. And if you thought that, you're right, it has been a while. But we want to start doing more regularly scheduled webcasts. So this one with Yubcco is an awesome start to a series that's coming. We think that all of these webcasts are a great way for all of us to stay up to date on the industry, to hear more from our partners, and also just to learn what GitLab's up to. So we're going to be doing more of these, and to stay tuned on our upcoming webcasts, you can sign up for our newsletter. There should be a link in the resources section on the bottom of your webcast console. So let's get started. We are excited to talk to you today about the pressing topic of security. My name is Amara. I'm a product marketer at GitLab, and joining me today is my team member, David, as well as Chris, a solutions engineer at Yubicco. So about a month ago, we announced our partnership with Yubicco. We noted that the reason why we were partnering with Yubicco was really to help our customers strengthen their authentication process by using YubiKeys. We've asked Yubicco to join us again today to talk about the key trends affecting the security of your team, to share examples about how both of our companies have built products to improve information security, and to discuss best practices. And then we'll close our session with a Q&A. So let's get started with introductions. So it's hard to introduce GitLab without first introducing Git. Git is the leading distributed version control system. It enables revision control because it allows for users to easily copy code and then propose changes before they make any formal changes to the source code. A number of developers have been using Git for personal projects for honestly a while now. And according to Gartner, 30% of developers are now starting to use Git in their enterprise jobs. Adoption of Git just continues to grow, and we really believe that that's because Git is a paradigm shift. It aligns with the way that people actually work. Development is collaborative, and Git has a unique ability to let developers work safely on the same project. So if Git is the method, GitLab is the tool. The reality is that while Git is great, it's really challenging to work with other team members using just the command line alone. So loosely speaking, we like to say that GitLab is the layer on top of Git that makes working together in teams a lot easier. More formally, GitLab is an integrated set of tools that supports the full software development lifecycle. Our goal is to help you move faster from idea to production. GitLab includes Git repository management software with fine-grained access controls. It includes code reviews and issue tracking, and we've even built in CI and CD. The reality is GitLab has a lot of really awesome features, and I didn't do them justice just now, but you can always keep up to date with what we're releasing every month checking out our release posts. So the primary reasons why customers choose GitLab is because they're looking for one or four of these benefits. They want to improve their collaboration across members of the team or even across all teams within an organization. They're really looking to reduce the development time by shortening feedback cycles. They want to apply control to both their development and their deployment process. And then they really want to focus on writing code that's unique to their business and not around configuring their tools. So there's three different ways to use GitLab. You can try our Community Edition, which is completely free. It's single tenant and it's our open source product. Or you can purchase our Enterprise Edition, which is single tenant as well, and it has more features that are synonymous with larger organizations. And then finally, you could use GitLab.com, which is our free hosted version of GitLab that actually runs our Enterprise Edition. So that was honestly just a quick high-level overview of who we are and what we offer and how you can use GitLab. I'd like to pass the baton over to Chris to introduce Yubcco. Okay, so Chris is actually having mic troubles. What I'm going to do is jump ahead in the presentation, and we'll come back to the section on Yubicco. Okay, so I wanted to highlight some of the key trends around security that are likely affecting your team. So as I noted before, a number of developers are starting to use Git in their enterprise jobs. However, these large organizations are still concerned and fearful of Git. And, it seems like the reason why they're so concerned is the fact that, all the things that make Git great are the fact that it is this distributed platform that is exceptionally developer friendly because it allows developers to collaborate more effectively. However, the challenge is that, given that it's distributed, it means that everyone has a copy of the source code on their individual machines. So this naturally heightens security concerns because it's assumed that the code is only as secure as the machines that it's copied to. And truthfully, it's the machines as well as the individuals. Anytime you add humans into the picture, there's always the concerns around human error taking place and your source code being compromised. So taking a quick look at some of the companies that have unfortunately fallen victim to huge security crises, one of the companies, unfortunately, was Heartland Payment Systems, where they had 134 million credit cards exposed through a SQL injection that installed spyware on all of their data systems. Gawker, the site that I'm sure we're all familiar with in one instance or another, compromised the email addresses and passwords of over 1 million blog commenters. And I mean, we can all admit to having used multiple email addresses or, the same password across multiple email accounts. So this is a very real concern. RSA Security had about 40 million employee records stolen. And Sony, who I'm sure we're all familiar with, lost millions of dollars during the month that they had to put their site down because they had over 70 million PlayStation Network accounts hacked. So these are 4 examples of security breaches that were caused by a number of different reasons and have affected a variety of different industries. And we don't bring this up to, instill fear in anyone. We honestly just wanted to shed light on the real security concerns that exist out there. InfoWorld wrote this really well-titled article about 12 security threats. They called them the Dirty Dozen and the Treacherous 12. And I'm not going to read this list, but it honestly does draw attention to the fact that there are a number of security concerns that affect your team, whether it's data breaches or compromised authentication or concerns with accounts being hacked or vulnerabilities in your system. There's so many things that can happen. And so the concerns around security are very real. And that's one of the reasons why we were excited to talk to you all about how both GitLab and Yubico approach security. So hopefully Chris has gotten his mic all set up. I will jump back to the Yubico slides now so that they can introduce themselves, and then we will pick up from there.
All right, can anyone hear me? Okay, it sounds like you guys can. I apologize for the delay. Let's try that one more time. All right, so I'm Chris Streaks. I work for Yubcco as a solutions engineer, and what I will be going through with you guys is an explanation of the solutions Yubcco provides from a security standpoint, not just for online services like GitLab, but also for any other kind of authentication needs that you may have. All right, so first and foremost, the mission statement. Yubcco was founded in 2007. We have offices here in Palo Alto, California, as well as around the U.S. It is a Swedish company, so it is actually, we have some Swedish offices as well, and some other offices around the European area. As far as customers are concerned, we have businesses not just with Google and Facebook, but other major manufacturing companies as well. So as the slide says, 8 of the top 10 internet companies are using YubiKeys in some fashion. Of course, the mission statement is to protect people as well as businesses, so we do have a large user base as far as individuals who just want to sign their code or sign their email or just use the YubiKey to log into various online services for various means. So I'd actually like to talk about the authentication landscape a bit. This kind of details out how exactly people are logging into their various services. So I'll start with the low security aspect of things, since this is what people are typically more familiar with. Just a username and password, or maybe I have an iPhone or an Android device that has some consumer biometrics in there. We consider these lessened security practices, especially if I'm just using something that is a single factor of authentication into a service, like a username and password. If I phish that from you, if I use some sort of man-in-the-middle attack, this is going to compromise the data that you are hiding behind that security wall of sorts. So the flip side of that, on the upper left-hand corner, we have solutions that are both high security, but at the same time, they are relatively complex to implement. So these are things like your traditional smart card, right? The device that I have to carry around with me, I have to stick it into a smart card reader and make sure that I have smart card drivers to use this, etc. These are going to add layers of complexity into my existing infrastructure for authentication. So somewhere around the middle of all of this is going to be your typical mobile device. So I talked a little bit about the consumer biometrics and that how that's built into your phone and that can secure you on some levels, but understand that your phone is still something that can potentially be phished. It's not going to be the end-all solution. Getting an SMS code from a given service to do my authentication is nice from a usability standpoint, but we can always make greater strides in terms of securing ourselves further, which is where the YubiKey comes in. So the YubiKey is something that Yubcco produces, and momentarily I am going to further explain exactly how this is going to protect you. Hang on one moment, just waiting for the slide to advance here. The YubiKey comes in 3 major form factors on your screen. So, number 1, you have your keychain form factor. This is something that I can tote around in my keychain. When I need to do my authentication, I walk up to my computer, I plug it in, and if you actually see in the picture there should be a gold capacitive switch right in the center. So this is something that Yubcco calls touch to sign. So I put in my username, I put in my password, and then I touch that center button to do my authentication. That physical touch is what is physically securing me for that particular authentication method. And that goes for the other form factors as well. So the second form factor you see there, this should be a smaller form factor that I have that I'll be able to authenticate without needing to tote something around on my keychain, for example. And the last variant is something that I can use for an Android device that supports NFC. So if I do need to log into, let's say, GitHub, for example, all I have to do is touch the key to the back of my phone, and I can do my authentication. So as far as how the keys are designed, we primarily build them here in the US. We also have a manufacturing plant over in Sweden. They're designed as a single molded piece of plastic, which makes them very durable. If you were to run these over, for example, generally speaking, you're not going to have a problem. This is kind of in stark contrast to other hardware-based tokens that you might see out there on the market. Things like RSA tokens, for example. They're much more fragile. Right? These are considerably more durable than their counterparts. And that's not just speaking to the durability of the keys themselves. from a security aspect as well, these have been thoroughly vetted to be devices that can be used in any kind of secure environment for your use case. So the YubiKey, as I mentioned, has the ability to take the place of a lot of these different authentication devices that I had mentioned earlier. We do this by allowing you to authenticate to a number of different services on the same exact key. So if I want to log into GitHub, for example, I can use the FIDO U2F protocol that I'll be talking about momentarily. If I want to sign my code, I would use the OpenPGP applet that's found on the device. If I wanted to use this as a smart card, that functionality is baked in as well. And for you DevOps out there, if I wanted to log into some sort of server or switch that is punched into over radius, for example, this can replace, without needing to do any extra work, my standard RSA Secure ID token or anything else that's using OTP. But since this is a GitLab presentation, I'm going to focus on the U2F protocol. Next slide, please. Okay, so the U2F protocol, very quickly. The methodology here is to replace your standard one-time passwords, OTP, with something that is a bit more secure. So if you're not familiar with OTP, it is a series of characters that I will either input into a screen or a text box somewhere myself, or it's emitted from a device, and then that string of characters is taken. If it's in some sort of different format, it's decrypted, and then that password is good for that particular instance for my authentication. The problem is, it's vulnerable to things like man-in-the-middle attacks, it's vulnerable to things like replay attacks, and this just is not going to work for the further security of our online services. So Yubcco, alongside with another partner of ours, Google, designed the U2F protocol. The way it works, it takes your typical public key infrastructure, where I might have a certificate authority, right, sitting in a server closet somewhere, and I have a client, and I put a certificate from my certificate authority onto a smart card, and then I can perform my authentication off of that smart card because I got it from that certificate authority. All right, so let's take all of that functionality and let's flip it on its head, right? And I'm actually going to place the certificate authority of sorts on the actual YubiKey, okay? And then I'm going to allow various websites to do authentication to this token instead. So what this provides us is a very secure method of ensuring that we avoid things like phishing attacks. We avoid things like man-in-the-middle attacks. And because we're not using the same exact underlying seed, the same exact OTP for a number of different services, this means that even if I have one token, you cannot use any data, even though it's unintelligible data from the token itself, to get access to other websites in the event that anything is compromised. Okay? Next slide, please. So talking specifically about U2F and our friends over at GitLab, you can use this for authentication into their services, much like how you would log into a Google account, for example. Google also supports the U2F protocol. All I have to do is walk up to that computer. I talked about this authentication process earlier. Walk up to the machine, put in my username, put in my password, plug the device in, right, and simply touch the gold capacitive switch in the center. Same exact user interface. I'm not having people learn how to use a whole different tool. This should be very straightforward. I can explain this authentication process to anybody. Right? Next slide, please. All right. So why might I want to use this over something like a cell phone, for example? The U2F protocol, as I mentioned, it is far less vulnerable to things like phishing attempts. Right? If somebody sends me an email and says, hey, I really need you to log into this service real quick, you're going to get a message on your device. Just make sure you send me those codes after that. And the unsuspecting individual actually goes ahead and does that. they're not going to be able to use any kind of information in a replay attack with the U2F protocol that we have here. So it's something that reduces the amount of man hours that I have to spend re-educating my users on how to use something. It reduces the amount of fraud that I'm going to be a part of, simply by the fact that I don't have to worry about phishing anymore, right? And it's just faster to log in. I don't need to involve my phone in any way to get this done. All I need to do is walk into the machine, username and password, and actually touch the device. Right? And next slide, please. Okay, so almost done here. Security trends. Biggest security trend that we're seeing, a lot of people are going to various vendors and they're effectively locking themselves into various things. Yubcco, at its core, is a huge fan of open standards. The U2F protocol is an open standard. If you wanted to spin up your own U2F authentication server today, you are more than happy to. In fact, we'll actually give you the references libraries to do so. We also have a Git page. Okay, so whether we're talking about smart cards, open source, U2F, open source, or OTP, all of these various things are going to be seen as methodologies that I can take advantage of when I'm talking about a YubiKey. The goal here is to allow for fantastic usability. Right? If people don't want or can't use it, that's going to be a problem. Without sacrificing security here. Right? And last slide, please. Okay, so just to answer this question before I have any of those questions in the QA, what happens if I lose my YubiKey? So I like to attest this to losing your car keys, for example. My suggestion would to be just configure multiple backup keys. Or if your solution allows for it, combine it with other methodologies that allow me to do things that would do SMS or security codes, other methodologies that let me back into the system, if at all possible. From a security standpoint, okay, so that was more usability. From a security standpoint, if somebody gains access to my YubiKey and I'm aware of it, that's fine. Okay, I can actually simply revoke that cert from my end, have that revoked. And at the end of the day, they still need my username and password. The YubiKey is primarily used as a second factor, and we like to stay that way. Right. So now that I'm done with the Yubcco side of the fence, I will pass the demonstration back on over to our friends over at GitLab.
Hey, thanks, Chris. Hello, everyone. My name is David Mountney. I'm a developer at GitLab. I'm going to talk and show some of the features that you can use to improve the security of your GitLab instance specifically. And we're going to be focusing a demo on the use of the YubiKey for two-factor authentication in GitLab. The two goals that we achieve by proactively securing your GitLab instance is to first try to avoid information breach of your private data, and the second is to provide a secure Git repository that you can trust as a trusted source of your data. Amara kind of mentioned it before that with Git being a distributed system, there's going to be copies of your Git repository on all sorts of different machines, developer machines, and it can be hard to when things go bad to have a single source of truth. Which one do you trust? And so picking one and securing it and ensuring that it's one you can trust is very important. You want to maintain a copy that you can trust that hasn't been compromised. We approach these goals through controlling who has access to change your repositories, giving you workflow tools and integration points to allow you to control the type of changes being made, and keeping a record and audit trail of what has happened in your repository, in your GitLab instance. So I'm going to go ahead and just give me a second to switch over to sharing my screen, and I'll give a brief demo. Okay. So here I have a GitLab instance. This demo is going to focus on we're gonna demo the YubiKey two-factor authentication experience with GitLab, and then while we're at it, we're going to do a little bit of talking about the other security features that we have in GitLab, and we're just going to run over some of the settings in GitLab to enable them. We won't be showing each of them in action, but we'll try to run over some of them. So this is an instance of GitLab I have running. I'm going to sign in. For demo purposes, I've enabled sign-ins from the same domain. Normally, ideally, you would have sign-ups turned off. I'm also using the default user management in GitLab, the one built in, and certainly there's other options for centralized user and identity management that I'll talk about in a minute. The reason why I have the sign up enabled turned on is I wanted to talk about that that first level of authentication, your password and your username. So this isn't a feature of GitLab itself, but kind of a best practice that we all know is that we should be using different passwords for each account we have, and ideally those passwords should be stored in an encrypted vault. So there's a bunch of tools that make that easy. Right now, these little icons that you see in the right are not part of GitLab. They're part of something I have installed called LastPass, which most people are probably familiar with. How LastPass is going to help with your first level of authentication is it's going to help you generate a strong password that's randomized and stored in this vault, and you likely won't be able to actually remember this password. Which is fine. You want LastPass or 1Password or KeePass to remember it for you essentially and have it kept in a safe place. This makes the barrier for people wanting to adopt a different password for each website a lot lower. And the tools that come with things like LastPass and 1Password make it very quick to actually enter the passwords into the website. In fact, you can have them just enter it as you browse the page, and have it log you in. So that reduces a lot of the pain that people find with having to generate a lot of these passwords. And reducing the pain is sometimes a good step to encouraging people to use good security practices. So I'm going to go ahead and log in as the root user because we're going to show some administrative the admin side of GitLab. I'm not using a random password yet on this particular demo account because it's easier for me to put in, and I don't want to show you all my LastPass sites. So we're going to sign in, and two-factor authentication is turned off currently for this user. We're going to go turn it on. So we're signed in. This user has access to the security group and the project YubiKey demo, which is specific for this demo. So as the root user, I'm going to jump to my user's profile, jump into the profile settings, jump into account, and we'll see we have this two-factor authentication option in your account. Currently the status is disabled, so we're going to hit enable. So I think someone already had a question in the Q&A pop up already about the UTF device and the fact that currently this is only working in Chrome. So as a result of it only working in Chrome and a couple other reasons, for example, that if you're using the YubiKey 4 and not the YubiKey Neo, that you wouldn't be able to have access to GitLab over on your phone. We provide an alternative way to do the two-factor authentication, and that's using a two-factor authentication app on your phone like Google Authenticator. So we make sure that you have this set up before you set up the YubiKey for that reason, that you will still be able to log in from other browsers like Firefox and on your mobile phone. So I have the app open. I'm just on my phone. I'm just going to set up the account and scan it. So one thing we have with the two-factor authentication for the Google Authenticator app is we have these backup recovery codes. So the intent now is that you'd probably print these off, you'd store them in a safe place. Each one of them is usable once in case you lose your phone and no longer have access to the authentication app. You'd want to use one of these to log in. In the case of losing your phone, whoever has your phone now has access to these keys, to your keys as well. Luckily, they don't have access to your password, but you would want to go in and disable it, or basically log into your account, disable two-factor authentication, re-enable it, and set it up on a new phone. So these backup keys are very useful. The Google Apps account for two-factor authentication also provides the same thing, but you actually have to go in and turn it on, these backup codes. I personally recommend doing that. So now we have the first level of two-factor authentication turned on. So if I logged out and logged back in, I'd be required to use the one-time password from the Google Authenticator app. I don't really want to do that because that takes a little while to type that code in. I'd rather use my YubiKey. So I have a YubiKey 4 with me, which unfortunately you can't see, but I'll describe it when it's doing stuff. So I'm going to go back in and manage two-factor authentication. And now I'm able to set up a new UTF device. So it's actually going to time out because I'm going to describe what's going on here. But the gold contact area on the YubiKey, on my YubiKey 4, is now flashing green, which is kind of cool, indicating that I should press it to authenticate here, or to register the device rather. So I'm going to try again. This time I'm going to actually press it when it's flashing. So it's set up, I register it, and that's done. So I'm going to log out and log back in to show you what that looks like. So we're back at the login page. Log back in as my user. And now I have the option of providing the code from the Google Authenticator app, or logging in via my YubiKey. Like I mentioned, because this isn't supported on any browser other than Chrome, we do prominently feature the Google Authentication Authenticator codes first for now. Support for Firefox is coming very soon, and then as things roll out over the course of the next few years, I imagine our defaults will change and things will move more and more. If you had a YubiKey device registered, certainly it would be encouraging you to use it by default. So we're going to log in via the UTF device. When I press this again, the contact area and the Y is going to start flashing green again on my YubiKey 4. I press on it and I can authenticate, and we're in. So that's logging in using the YubiKey and setting up the two-factor authentication. What I'm going to show now, and the reason I logged into the admin account to do, is now that we have it set up on our root account, we can actually enforce it across all of our accounts on GitLab. So if we go into the admin area and we click down this little gear and go into settings, these are the settings for all of for the GitLab instance itself. If we scroll down to sign-in restrictions, we can now require all users to set up two-factor authentication, and we have a two-factor grace period of 48 hours, which you can configure, which is 48 hours after they sign up for the site. So I'm going to save this, and then I'm going to log in as another user so you can see what that looks like. So I have another browser here. I have another user. Now when they log in, they immediately come to this page that has them suggested to register with two-factor authentication. We have this message that says you must do it before this date, but you have up until that point to do it. Otherwise, you can configure it later. So now that we've kind of shown that's kind of the meat of the actual demo. Now we're going to talk a little bit, talking a little bit about the other features related to security and with GitLab. So one of the things that I'm not able to demo because of the way I set up this instance, but is certainly something that's recommended, is if in your company already that you have some sort of centralized user management system, that we have some sort of integration with it with GitLab. We support LDAP. We support for single sign-on solutions, we support SAML and Kerberos. And if you want to look at how to set any of those things up, you just go to docs.gitlab.com, and in the search bar, you can see, if you search for LDAP, you'll see information on setting up LDAP and the LDAP integration. Same with SAML, and same with the Kerberos integration. So some of the advantages of using the centralized user management like LDAP are that when things do get compromised, or a user account is compromised, there's a single place where you can change that user's password and that access. Also, if you need to block users or remove users, that there's a single place that your IT team can go in and remove that user across all of your accounts. And as long as you attempt to make as many applications in your company as you can authenticate via LDAP, that you'll be more confident about not forgetting that last access point for them to log in. The single sign-on capabilities are a little bit of an added benefit. They don't add so much security-wise, but they're part of that low barrier to entry that encourages people to act well. I guess with LDAP and centralized user management, you can actually have the opportunity to enforce certain requirements very easily enforce certain login requirements across your applications and password requirements. The single sign-on makes it very simple in that if they've signed in to one of the applications today, that when they go to log into any of the other applications in your business, that it's likely just 2 clicks and doesn't actually involve sending their password again. So it doesn't really add a security constraint, but the fact that it's so easy makes people more likely to use good passwords, to use your security infrastructure. So that's the centralized user management. Back to the actual settings of the application, we'll talk about access permissions a little bit. So this root user had access to the security group and the YubiKey demo project. So if you're not familiar with GitLab, we have groups and projects that you can set roles and access on. So I'm going to go to the security group, which has the project YubiKey demo. I'm going to go to members. You can see it has 2 members. It has the root user and that other user we were looking at, and they're both owner users. So the roles that we have in GitLab break down into guest, reporter, developer, master, owner, and each of those have their own sets of permission levels outlined in this doc here. I'm not going to go through all of them. It's quite the extensive list of what they can do, what they can't do. But you can make use of these rules to tightly control who has access to your Git repository and what they're able to do. Some of the things that are worth mentioning in here that we're actually going to look at is this idea of protected branches or non-protected branches. So I'm going to jump back into the project itself and show you our protected branches. So this is the protected branches page right now. So my project only has 2 branches right now. It has master. It also has a branch called release. Protected branches has a couple purposes. One of the purposes is because in Git you can actually rewrite history. That's not something that really lends to very much trust in your repo. So the first thing that protecting a branch does in GitLab is ensure that you can't rewrite history in that branch. So any change, any non-fast forward push to the branch will be rejected. You aren't able to, while it's protected, to change its history. The other thing it does is protected branches by default aren't going to allow anyone other than the owner role to push to the branch at all. That can actually be configured. So you can see we have this developers can push option on your protected branch. That allows, so your developers are usually the role you would assign to people who you would expect to be able to create branches and push merge requests and stuff like that. So by selecting developers can push to master, that enables them to do that. We have this additional option here that says developers can merge. If you turn that on and you turned off can push, they wouldn't be able to push directly to master, but they could accept merge requests. And where that becomes powerful is when you have rules around what is an acceptable merge request. So we'll just jump into that now. So one of the things that you would want to set up if you were setting up the fact that developers can merge but they can't push is required approvers. So we're going to go into the project settings. And we have this option for approvals required. So you could set this to a certain number of approvals required, and until it's reached that number, a merge request has reached that number of approvals, the developer, even if they can merge, that merge request is unmergeable at the moment until those approvals come in. So even though if they come in, the developer would be allowed to merge, they can't until it's done. You can also specifically assign approvers to the project so that for sure these people have to approve before it goes in, and then you would want to check this option as well, which you make sure that merge requests can only be merged if a build succeeds. So we'll talk about builds right away actually. So we build CI right into GitLab. So the built-in CI, once you set up jobs for testing your code, if those tests fail, your merge requests are blocked from being merged. So that's another place where you're in control of kind of the workflow of what you trust to get into your Git repository. So while I say tests, they could be any sort of enforcement of rules. In addition to the built-in CI, we have webhooks and other integrations that allow you to send events out to your various tools that manage this sort of trust management relationship. So when you push code, when you create a merge request, that they're notified and they have an opportunity to then respond back and say, no, this isn't good enough, this can't be merged yet, in an automated fashion. We also support something called push rules in the Enterprise Edition. So here are the push rules. This is a UI around Git hooks that allow you to make sure that you can set that authors have to be existing GitLab users. So by default, the pushing person in Git, the person pushing the code has to be a GitLab user and has to authenticate. But all the commits that they're pushing doesn't necessarily have to belong to existing GitLab users. So you can ensure that's the case. You can make sure commits are only coming in from emails that are registered at your domain. You can also prohibit certain things from being uploaded into your repository, similar to using a git ignore file, but enforcing it right on the Git hooks themselves. So this is the ones available kind of with a nice UI in the EE version, but you also, as a administrator who has access to the box that GitLab's running on, you can go in and set up any normal Git hooks in the pre-receive and post-receive phase of accepting commits from people. That ensures they could do anything really, but ensure that the commit coming in meets your requirements, so that you can trust what's going to come into your repository. The other thing, so we talked about roles a bit in this particular project. The other option is you can force users to not have any access really to your project, but have to fork your project in GitLab and provide merge requests from their controlled fork back into your project as well. So another feature, somewhat security feature, but somewhat Just a nice feature of on top of Git is our file locking feature in the EE edition. So I'm just going to jump back to the project and show you the file locking feature in action. It allows you to lock a directory or a file so that only you can edit it. The initial idea behind it is that sometimes the files that you're working on aren't easy for Git to merge. This, for example, would be an image file. In this use case, I only have text files in here, which usually can be merged and usually can have multiple people working on it at the same time. But in the case of an image file, for example, it would be really unfortunate if two people working on it at the same time, because it's not easy to merge their work. So what you can do is you can go in and lock the file. And what the lock does is ensure that only your user has access to it. That includes from the UI editing it, or being pushes on the command line in Git up to GitLab. It will reject any pushes while you're locked. So I'll grab the other browser I had open here and just show you quickly what that looks like. So I can see that this file has been locked. This is my other user, and I can edit it. This kind of matches the behavior that you would get in Git on the developer's machine. Even though it's locked, they can do whatever they want on their own box. They can attempt to edit the file. It's really when they go to push it to the server that it would reject them. So the same thing happens. I'm just going to show it in the UI though, that you can see that the file has been locked. I'm going to go ahead and unlock it. In addition, so just to jump back for a second and talk about, so it's kind of been a theme here, and it's going to continue being a theme that I'm talking about a trusted repository. And it's not just a trusted repository, it's specifically about trusted branches. So you saw I had the master branch protected. That's protected by default. I had a release branch. That would probably also be protected. And I talked about how that allows you, or it enforces that history isn't going to be changed in those branches. We also have control in the UI for actually reverting some commits. And the feature in the UI for reverting commits, it doesn't change history. What it does is it creates a new change that removes the content that you made in your commit change and commits that as something new. And so your audit log shows all of those changes. Your Git log shows all those changes. So history hasn't been rewritten. So kind of the final piece. So we went over like authentication, and we went over a little bit of access, and then we went over a little bit of the workflow controls. So in terms of workflow, things like CI and other integrations enforcing a certain level of quality in the merge request in your commits coming in, so that you can trust what's coming in, that they meet your requirements. So the final piece is kind of like after everything has happened, where can you look to see what has happened? So in GitLab, the activity view will show you all the things that have been happening in the repo, the pushes, the merge events, the comments. The commit graphs will show what commits have come in. We have an audit log for what changes you've made to users' permissions. So there's that both on the group level and the project level. So here in this group, if I jump into audit events, you can see there's only one audit event, but I added owner access to the administrator user. All these are tracked, any change in access, any addition, any granting or removal of access. In addition, we have monitoring tools that you can set up. By default on the box itself, many things are logged, but you can also set up things like metrics, but more importantly, in this case, error reporting and logging through Sentry. We also have, in the EE edition, we have configuration for remote logging. On the box itself, the most important logs on the box itself would be the shell logs, and the shell logs is what actually manages the Git repositories, and they kind of log everything that goes in and comes out, and all the access to your actual Git repositories on disk. And that's it for the demo. I'm just going to transition back to slides here. Just give me a minute. Okay, so just a quick recap. I'll probably skip most of the recap, but we talked about access permissions, workflow management, and an audit trail. I'm going to jump ahead to best practices because we're running a little bit behind. And I'm not going to read through all these the security best practices, and there's certainly more than 9 security best practices. And these security best practices aren't specific to GitLab; they're kind of pointed at security in general and Git repositories. Some things I'll point out on this best practices is on number 1, storing your passwords in an encrypted vault. We say example 1 password, but LastPass, KeyPass, stuff like that are all great options. Number 3, make sure everyone has their own user accounts, so people aren't sharing user accounts, because that makes it very difficult and makes it kind of a pain when, for some reason, one of those people leaves and you need to change the password on that shared account. That kind of is a pain for everyone else, and you might even forget to do it. So it's best to have everyone have their own identity. Obviously, enforce 2-factor authentication. Number 5 is the one that we've been talking about a lot today, which is maintain a single secure repository. And that doesn't mean that you only have one repository, because with Git you're going to have copies on all your developers' machines. What it means is that you have one place that you trust as your source of truth, and when you need something from your source of truth, that you know where to go, and that you spend time in that repository securing it down via these other methods, which include reviewing who has access to what in that repository, and not just taking the defaults for granted, but actually going through the application and looking at all these settings and making actual decisions on how you're going to secure things. And then the only other one I want to mention is number 9, usage of the git ignore files. So in GitLab we have a template for your git ignore files, but regardless of what solution you're using, even if they provide a git ignore file template for your Git repository, you should actually read through that git ignore file and look for things that you need to add. So the git ignore file is going to prevent things on people's production boxes, if they're actually using Git on the production box, or things on their developer machines in their Git repository they don't actually want shared on the server. One of the big things that has happened over the past couple of years is a lot of people have accidentally uploaded their AWS or committed their AWS keys to GitHub, for example, and by accident, or they have a dump of the database of their own production database stored on the file system, and it ends up being committed by accident in Git. And so these git ignore files are very important for making sure you remove those folders and areas that you don't want to ever make public. That's it for me. I'll pass it back to Amara for questions.
We'll go ahead and answer your questions over email, and also we'll be sending out an edited version of the recording so that it's much easier to follow along without the long pauses. Thank you everyone for joining, and we will see you all next time.